Good morning, students. This is NECO Chemistry, the one that was written on the 28th of July 2021. It has been written. So, NECO means National Examination Council, written here in Nigeria. So, as I've told you in physics, when I solved the questions in physics, that NECO was written this year before WAEC, West African Examination Council. But we used to have WAEC before NECO. Okay, so my explanation in this particular chemistry and your understanding will make you to be able to do well in the forthcoming WAEC that is coming up in the next few weeks. Okay, so because the topics that they are almost the same thing, almost like 95% the same thing, or if not 100% self are the same. So this is it, NECO Chemistry. So I will start with the objective part first, and let's see how many questions we can be able to solve from 1 to 60. If we did not finish it, then we are going to, the remaining ones will be in the second. I will continue in the second part. Okay, as in let's time this one part 1. Then if we did not finish it from 1 to 60, then we time the rest part 2. Okay. All right, let's start from number 1. Number 1. Okay, you can bring out a paper and pen so that we can jot something down. Let me drink water first. Water is life. Yeah, water is chemistry and chemistry is life. H2O. All right. Number 1. An increase in the pressure of a gas results in the decrease of it. An increase in the pressure of a gas results in the decrease of it. Option A, concentration. Option B, mass. Option C, temperature. Option D, vapor density. Option E, volume. An increase in the pressure of a gas results in the decrease of it. So when you look at this question, you should know that you can see that the question is talking about Boyle's law. Boyle's law, talking about Boyle's law. Boyle's law. Okay, Boyle's law. So one of the gas laws. Boyle's law states that the volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. The volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. So it means that if volume increases, pressure will decrease. If volume decreases, pressure will increase. Are you there? So let's look at the question. An increase in the pressure of a gas. So when pressure increases, then what happens to the volume? It will decrease. Of a gas result in a decrease of its A, concentration, B, mass, C, temperature, D, vapor density, E, volume. So our correct answer is volume. So for number 1, the correct option is option E, volume. Let's go to number 2. During the extraction of iron, limestone combines with acidic impurities. Limestone combines with acidic impurities in the blast furnace to produce. During the extraction of iron, limestone combines with acidic impurities in the blast furnace to produce option A, carbon 4 oxide, option B, carbon monoxide, option C, iron 2 oxide, option D, oxygen, option E, slag. So you can see that in the furnace where iron is being produced, where iron is being produced, there are three core materials. There are three core or raw materials that are used in producing iron in the blast furnace. First is the iron ore itself. The iron ore could be hematites. Okay. Then we have coke. That coke is carbon, right? Then the third one is limestone. So these are the three major raw materials that are used in producing iron in the blast furnace. Okay, so take note of all these. It could be a question in the forthcoming examination. Okay, whether in JAMB, whether in WAEC, whether in IGCSE and all that. Okay, now this limestone is calcium carbonate. It decomposes in the presence of heat. The heat from the furnace, we break this calcium carbonate into calcium oxide plus carbon 4 oxide. Are you there? So the carbon 4 oxide release will be attacked by the coke. Coke is carbon. So the coke, which is carbon, will reduce the carbon 4 oxide into carbon 2 oxide. So, and you balance your reactions like that. So then the carbon 2 oxide will now come and reduce the iron ore. That's iron 3 oxide, hematite. So we reduce iron ore into iron plus carbon 4 oxide. Okay, so this is the limestone we are talking about, calcium carbonate. So there are impurities. This iron ore has impurities, has earthly impurities that you don't need. So how can you remove the impurities that come along with the iron ore in the blast furnace? So that is another function of that calcium carbonate, the limestone. It will react with the acidic impurities. If there's any acidic impurities around the iron, it will react with it to form slag. To form what? Slag. SLAG. So the slag will float at the surface of the iron itself. In the blast furnace, this iron produced will settle at the bottom. We settle at the bottom of the furnace, while the slag will be at the surface. So it will be at the surface, we float at the surface, so it can be collected, it can be run off. Okay. So they said that during the extraction of iron, limestone combines with acidic impurities in the blast furnace to produce option A, carbon 4 oxide, option B, carbon monoxide, option C, iron 2 oxide, option D, oxygen, option E, slag. So the correct option is slag. Number 2, option E is the correct answer for this 2021 NECO. Sorry, this is 2021 NECO. Okay. Number 3, let's look at number 3 question. Number 3 question is a calculation question. 12 grams of water is saturated by 15 grams of potassium chloride at 20 degrees Celsius. 12 grams of water is saturated by 15 grams of potassium chloride at 20 degrees Celsius. Calculate the solubility of potassium chloride at 20 degrees Celsius. We are given the atomic mass of potassium as 39, of chlorine as 35.5. 12 grams of water is saturated by 15 grams of potassium chloride at 20 degrees Celsius. Calculate the solubility of potassium chloride at 20 degrees Celsius. Okay, so this particular question is talking about solubility. So what's the formula for? Okay, let's list the parameters first. Let me just wet this thing a little bit. Okay, all right. So let's have the parameters written on the board. So we're given the mass. 12 grams of water is saturated by 15 grams of potassium chloride. So mass of potassium chloride given is 15 grams. Okay. Then 12 grams of water. Mass of water given is 12 grams. It's 12 grams. It's 12 grams. So at 20 degrees Celsius, you don't need temperature. You're not working with temperature. Temperature is just the condition at which the solubility took place. Okay. the solute, which is the potassium chloride, is dissolved in water. Water is solvent. Just like when you drop a cube of sugar in water, it dissolves. Okay, potassium chloride is a soluble salt. So when you put a pinch of it inside water, it dissolves. So to what extent does it dissolve? That is the solubility we are talking about. Okay. Now, mass of potassium chloride given is 15 grams. Mass of water given is 12 grams. First, what is the formula for solubility? Solubility equals to number of moles all over volume in dm cube. Number of moles all over volumes in dm cube. That's solubility. So that does not mean the unit is mole per dm cube. Mole per dm cube. That does not mean that it cannot be in gram per dm cube. We can also have solubility as mass of the solute all over volume of the solvent. Are you there? Mass of the solute all over volume of the solvent. In that regard, it will be in gram per dm cube. So in gram per dm cube. So let's work in moles per dm cube as the solubility. So number of moles of the solute, the number of moles of potassium chloride over volume of the solvent. Okay, we are given the solute is potassium chloride. Is given in mass 15 grams. So let's convert it because the options here are given in mole per dm cube. The solubility based on the options is given in mole per dm cube, and that's the reason why I want to work in mole per dm cube. So let's go out. We have to go and convert this mass of the solute of potassium chloride to moles. So we know that number of moles equals to mass over molar mass. Number of moles equals to mass over molar mass. So the mass of the potassium chloride is 15 grams. What about the molar mass? So you have to go and calculate the molar mass of potassium chloride. So let's calculate the molar mass of potassium chloride. Molar mass of potassium chloride. Molar mass of potassium chloride. Molar mass, capital letter M. So potassium chloride is K. K is given as 39. You had the atomic masses together. So K 39 plus chlorine is 35.5. So when you add this one together, what do you have? You have 39 plus 35.5, and that's given us 74.5. So 74.5 grams per mole, and that is the molar mass of potassium chloride. So we now come back here into number of moles equals to mass over molar mass. What is the mass of the potassium chloride? Okay, we have converted it to okay, we have the molar mass as 74.5 grams. So now come back here. What is the mass of potassium chloride? 15 grams. 15. Are you there? All over. The molar mass of potassium chloride 74.5. 74.5. So 15 divided by 74.5 will give us 0.20. 0.2. That's 0.2 mole. So it's 0.2 mole. So we have converted the potassium chloride into moles. This is the potassium chloride in moles, 0.2 mole. So we can put this here, number of moles. So we can put this one here in the numerator. Now for the denominator, the volume in dm means the volume of the solvent. And what is solvent? Water. 12 grams of water is saturated by 15 grams of potassium chloride. So 12 grams of water. So that 12 grams of water, you have to convert the mass of that water. It must be in volume. If you can recall vividly in physics that the density of water at room temperature is 1 grams per cm cube. It can also be 1,000 kilogram per meter cube. Are you there? Yeah, 1,000 kilogram per meter cube or 1 grams per cm cube. So let's use, since the mass is in grams, let's make the density in gram per cm cube. Okay, so density of water, density is equals to mass over volume. This is a formula in physics, right? Density equals to mass over volume. So we say that the density of water at room temperature is 1 gram per cm cube. 1 gram per cm cube. So the mass given in the question, mass of water is 12 grams. So all over volume. So when you come on the plan, you find volume as what? 12 cm cube, 12 centimeter cube, 12 centimeter cube. So we are telling you that 12 grams of water means 12 cm cube of water, using the density as 1 gram per cent. The density is not given in the question, but it's constant. Density of water is constant. Are you there? So we just know that 1 grams of water is equivalent to 1 cm cube, because the density of water is constant, and which is 1 gram per cm cube. So this 12 cm cube now, we have to convert it to dm cube, because we need, they said we should find the volume in dm cube here. Are you there? So 12 cm cube in dm cube, you divide by 1000, that's 12 over 1000, we give you 0.00012 dm cube, 0.012 dm cube. So this is the volume in dm cube. So we have got the volume of the solvent, which is the water, in dm cube. So let's now go back to this, our formula. Solubility. Solubility is equals to number of moles over volume in dm cube. The number of moles gotten is 0.2 mole all over the volume. The volume of the water is 0.012 dm cube. So 0.012 dm cube. Okay, so let's divide that. We have 0.2 divided by 0.012, and that gives us 16.7. And that gives us 16.7 mole per dm cube. 16.7 mole per dm cube. So that is the answer. Let's look at the option. Option A 3.5, option B 10.7, option C 16.8, option D 27.0, option E 74.5. Option A 3.5, option B 10.7, option C 16.8, option D 27.0, option E 74.5. You can see that our correct option is 16.8. 16.8 and 16.7. It's just due to my approximation. When I was approximating, that was why we have 16.7. Are you there? So 16.8 mole per dm cube. Are you there? So our option C is the correct answer for number 3. Option C is the correct answer for number 3. Okay. Now number 4. A plastic which cannot be softened by heat is called. A plastic which cannot be softened by heat is called. We have option A neoprene, option B paspes, option C polypropylene, option D thermoplast, option E thermoset. So a plastic which cannot be softened by heat is called. We have two types of plastics. We have the thermoplastics and the thermoset. The thermoplastics and the thermoset. So the thermoplastics are plastics. Thermoplastics are plastics that can be softened by heat. They can be softened, they can be remolded when they are heated. They can be softened by heat. Are you there? So, but the thermoset, they cannot be softened by heat when they set, when they becomes hard. Are you there? They cannot be softened by heat. They cannot be softened by heat when they set. Okay, that is some thermoset. So, a good example is bakelite. A good example of thermoset is bakelite. Okay, and then you can see your socket on the wall. The socket on the wall inside your room. The socket on the wall inside your room is a good example of thermoset. So it cannot be softened by heat either. It cannot be remolded. Okay, so let's look at the options again. A plastic which cannot be softened by heat is called option A neoprene, option B paspes, option C polypropylene, option D thermoplast, option E thermoset. So option A is wrong. Neoprene is an artificial rubber. Then paspes is a glass-like plastic. Glass-like. Then polypropylene is obtained from the polymerization of propane. Are you there? So that one, polypropylene is a good example of thermoplastics or thermoplast. Okay, so Thermoplast is when the plastic can be softened, can be remolded. Then option E, thermoset. So thermoset is the correct answer. Thermoset is the correct answer. So a plastic which cannot be softened by heat is called thermoset. Number five, the reaction between alkanoic acid and alkanol in the presence of a mineral acid is known as. The reaction between alkanoic acids and alkanols in the presence of a mineral acid is known as option A, dehydration, option B, esterification, option C, hydrolysis, option D, polymerization, option E, saponification. Now, what is dehydration? Dehydration is the removal of water molecules from a chemical substance. Is the removal of water molecules from a chemical substance. And that removal of water molecules from chemicals affects the chemical composition of that substance. It affects the chemical composition of that substance. So option A is wrong. Okay. Esterification. Esterification is the correct answer. Esterification is the process by which an alkanoic acid reacts with an alkanol in the presence of a mineral acid as a catalyst to form esters and water. A good example of alkanoic acid is ethanoic acid, the old name known as acetic acid. That is CH3COOH. That's ethanoic acid. Ethanoic acid reacts with, that is CH3COOH. Okay, CH3COOH plus. And a good example of alkanol is ethanol. Ethanol is the second member of alkanol as an homologous in the homologous series. Okay, so alkanol, that's C2H5OH. C2H5OH. Okay, so when ethanoic acid, whose old name is acetic acid, reacts with ethanol, the product will be CH3COO C2H5 plus what? H2O. Are you there? So this is ethyl ethanoate. Ethyl ethanoate. So is under the homologous series known as alkanoate. Okay, so which is ester. So this is a good reaction under esterification. So esterification is the correct answer. So when you look at hydrolysis, option C, let me just look at another option. Option C, hydrolysis. So hydrolysis is when a chemical substance is when water is added to a chemical substance. Okay, that's not the answer. Polymerization. Polymerization is not the answer either. It's not the answer. Polymerization is a process by which two or more monomers, whether like or unlike, two or more monomers combine together to form a polymer. Are you there? So like the monomer of protein is what? Amino acid. So thousands of amino acids combine together to give the protein. Protein is a polymer. Amino acid is a monomer. So that's not the answer. Saponification. Saponification is the process by which fat or oil combines with caustic soda to produce soap and glycerol. So that's not the option. That's not the answer. So the correct option is what? Esterification. So number 5, the reaction between alkanoic acid and alkanol in the presence of a mineral acid is known as esterification. So let's go to number 6. For number 6, we are having the reaction between sodium hydroxide solution. The reaction between sodium hydroxide solution and nitrogen 4 oxide gives. The reaction between sodium hydroxide solution and nitrogen 4 oxide gives. Option A, water and sodium nitrite. NaNO2. Sodium diosonitrate 3. Option B, water and sodium nitrate, that is sodium triosonitrate 5. So option B, water and NaNO3. Option C, water, NaNO2 and HNO3. HNO3 is nitric acid or triosonitrate 5 acid. Option D, water, NaNO3 and HNO3. Option D, water, NaNO2 and NaNO3. So what are they trying to test us on here? It said the reaction between sodium hydroxide solution and nitrogen 4 oxide gives nitrogen 4 oxide. Nitrogen 4 oxide is a gas. Nitrogen 4 oxide, NO2. Nitrogen 4 oxide is a mixed acid anhydride is a mixed acid anhydride. At the same time, it's an acidic oxide. We all know that it's an acidic oxide. Do you understand that when it is bubbled into water, acid is produced? But unlike CO2, when you bubble CO2 inside water, you have carbonic acid, or you call it triacylchlorophoric acid. But this NO2 is special, is a mixed acid anhydride. That is, when you bubble it into water, it will form two different acids. It will form HNO3 and HNO2. Are you there? But this question, they bubble into sodium hydroxide. So when you bubble nitrogen oxide gas into sodium hydroxide, you also have two salts. You have two salts. So the salt would be sodium nitrate, this sodium triosonitrate 5, and sodium diosonitrate 3. Sodium diosonitrate 3. Are you there? So plus water. Plus water. So we're having the two major products are this. Practically, the two major products are this. Water will just make it to be in form of solution. Aqueous solution, aqueous state. Okay. So NaNO3, NaNO2, and what? Water. Sodium triosonitrate 5 and sodium diosonitrate 3. Okay, and water. Those are the products. Don't forget that nitrogen oxide is a mixed acid anhydride. So option A, water and NaNO2 wrong. Option B, water and NaNO3 wrong. Option C, water, NaNO2 and HNO3 wrong. Option D, water, NaNO3 and HNO3 wrong. Option E, water, NaNO2 and NaNO3. Confirm. So for number 6, option E is the correct answer. Let's go to number 7. That says, consider the reaction represented by the equation below. Consider the reaction represented by the equation below. So let me write the equation on the board. So that we can see it clearly. So we have hydrogen gas is given. Hydrogen gas in gaseous state plus iodine in gaseous state. This iodine in gaseous state is iodine vapor. You know, at room temperature, iodine is solid. When you look at group 7, iodine, the halogens. So, but this one is in vapor state. Reversibly reacts to give 2 moles of hydrogen iodide, also in gaseous state. Then we are given the delta H as negative. Okay, delta H, this means change in enthalpy. When there are 2 things that are involved, I mean the significance of this delta H. When enthalpy change is negative, it means that the chemical reaction is exothermic. It means that heat is released to the surrounding. It's just like when you just put a sample of detergent inside water and use your hand to stir it, it becomes hot. That means heat is released to the surrounding. So when delta H is negative, it is an exothermic reaction. So that's one fact about delta H being negative. But when it is positive, it means that the chemical reaction is endothermic. It means that heat is absorbed from the surrounding. For example, when you look at aqueous ammonia, that is ammonium hydroxide. So when you feel it, you find that it will be cool to your hand. It will be cold to your hand. Another example that you can easily understand is methylated spirit. When you put methylated spirit on your palm, it cools you. That means it has been absorbed from the surrounding. That's a good example of endothermic reaction. But that's not where we are going. Oh, this is a reaction, right? Reversibly. They said, which of the following takes place when the temperature of the reaction vessel is decreased? As in, what happens when the temperature of the reaction vessel is decreased based on this particular chemical equation? Now, another important thing about delta H is that when the reaction is negative, it means that a decrease in temperature favors the forward reaction. The forward reaction is when hydrogen gas reacts with iodine gas to give hydrogen iodide. That's the forward reaction. But backward reaction is when hydrogen iodide decomposes to give hydrogen gas and iodine gas. Are you there? So from left to right is forward reaction, but from right to left is backward reaction. So whenever delta H is negative, a decrease in temperature favors the forward reaction. That is, decrease in temperature, lowering the temperature of the particular system. Alright, so let's look at option A. More of hydrogen iodide decomposes. No, more of hydrogen iodide does not decompose. If more of hydrogen iodide decomposes, it means that the reaction proceeds in a backward reaction. That means it moves in a backward direction. That's wrong. Option B, the concentration of the reactant remains constant. No, the concentration of the reactant does not remain constant. So concentration has something to do with this enthalpy change here. Okay. Option C, the gases condense. No gas is condensing here as far as this delta H is, because temperature goes with the sign of the enthalpy change. Temperature goes. They say which of the following takes place when the temperature of the reaction vessel is decreased. So temperature goes with the sign in the enthalpy change. So we are not talking about gases condensing here. Option C is wrong. Option D, the yield of hydrogen increases. This is hydrogen gas. If the yield of hydrogen increases, it means that this hydrogen iodide has decomposed to give this. That is a backward reaction. That's a backward reaction. So I told you that when temperature is decreased, the forward reaction is favored for delta H being negative. Option E, the yield of hydrogen iodide increases. The yield of hydrogen iodide increases. That means more of hydrogen iodide is formed. So that means this and this react together to give more of this. That is a forward reaction. So delta H is negative. So forward reaction, more of hydrogen iodide is produced. So that is the correct option. Option E is the correct option for number 7. Okay. Let's move to number 8. Number 8, which role does sodium chloride play in soap preparation? Which role does sodium chloride play in soap preparation? In soap preparation, which role does sodium hydroxide play in soap preparation? You know, before now, I told you that saponification is a process by which fat or oil react with caustic soda either to produce soap and what? Glycerol. We have soap, we have fats or oil reacting with caustic soda to give soap plus glycerol. Okay, now when you prepare this practically, you find that the glycerol and the soap, they will be together as a product in the reaction vessel. So there's a need to separate this glycerol from the soap. And what you use to separate glycerol from soap is salt. We call it sorting out. You can come across that in theory. It says sorting out. What is sorting out? Sorting out is the addition of common salt in the preparation of soap in order to separate the glycerol from the what? Soap. So that's just that. Let's look at the options. Which role does sodium chloride play in sodium preparation? A, it accelerates the decomposition of fats and oils. That's a blatant lie. Nothing like a decomposition of fat and oil there. Option B, convert the fatty acid to sodium salt. No, it's not converting fatty acid to sodium salt. Are you there? C, purifies the soap. The salt is not a purifier as far as this particular chemical reaction is concerned. Option D, react with glycerol. No, it doesn't react with glycerol. Glycerol is just one of the products of the saponification process. Then option E, separate the soap from the glycerol. Yeah, separate the soap from the glycerol. Okay, that is the correct answer. So option E is the correct answer. Sorting out the common salt, separate the soap from the glycerol. Let's go to number 9. Number 9. Chemical change includes the following except. Chemical change includes the following except. First and foremost, you reason out. There are two types of changes in chemical reaction. Are you there? We have, in reactions in chemistry, we have the physical change and the chemical change. the physical change and the chemical change. A physical change is a change in which no new substance is formed and the reaction is reversible. Are you there? For example, when you put a cube of sugar in water, the cube of sugar dissolves. You will not see it again, right? It dissolves. So it becomes sugar solution. That sugar solution is not a new product. It's not a new product because you can get the sugar back from the water. Are you there? To a layman, the layman will say, "How? The sugar has disappeared, dissolved. How can you get the sugar back from the water? What are you talking about?" That is to a layman. But to we, the chemists, it can be gotten back. How? By the process of crystallization. Are you there? You can use crystallization method to get the sugar back. Are you there? You can as well use evaporation if the sugar will not decompose on eating. Do you understand? And without that, you have to use crystallization to get it out. Okay, that means it is what? Reversible. A physical change is a change in which no new substance is formed and it is what? Reversible. But in a chemical change, new substances are formed, but it is irreversible. For example, when you burn a piece of wood, at the end of the day, you see the wood ash there, which is black in color. Then you see film, smoke. You see smoke. That smoke is a gas released from the wood. Are you there? So can you combine the gas that is released with the ash together to get the wood back? Oh, it's impossible. So you can't combine the gas that has been released into the atmosphere with the ash back to get the wood. So that is irreversible. Are you there? So let's look at the options. Option A, the composition of which of chemical change includes the following except. Option A, the composition of green leaves in a compost. That is a good chemical change. Option B, the solution of sugar in water. Good. That is a physical change. Fading of colored clothes is a chemical change. D, fermentation of glucose is a chemical change. Rusting of iron nails is a chemical change. Are you there? So rusting of iron nails occurs in the presence of moist air. So our correct option is what? Option B, the solution of sugar in water. That's number 9. Option B is the correct answer. Number 10, they said, given that, this one is a calculation question, given that 32 grams of sulfur contains 6.02 times 10 raised by 23 atoms. 32 grams of sulfur contains 6.02 times 10 raised by 23 atoms. How many atoms are there in 2.7 grams of aluminium? Given that 32 grams of sulfur contains 6.02 times 10 raised by 23 atoms. How many atoms are there in 2.7 grams of aluminium? You see, that 32 grams of sulfur that contains 6.02 times 10 raised by 23 atoms, you don't need that. Are you there? You don't need that. It's just a way of telling you the Avogadro's number. So 1 mole of any substance contains that Avogadro's number, and that Avogadro's number is 6.02 times 303 atoms or molecules. Is that taken? So we are going to concentrate that 1 mole of any substance, let's say 1 mole of an element contains 6.02 times 10^3 atoms if it's an element. But it's a compound. It's a 1 mole of a compound contains 6.02 times 10^3 molecules. Are you there? Since we are talking about aluminum here, we are going to use element. So 1 mole of any element contains 6.02 times 10^3 atoms. Okay, and 1 mole of an element is the same as its atomic mass. The atomic mass are constant numbers in the periodic table. Okay, so 1 mole of any element is equal to its atomic mass. We have given atomic mass of aluminum here as 27. So that means 27 grams of aluminum, which means 1 mole. contains 6.02 times 10 to the power 23 atoms. Okay, now look at the question. They say how many atoms are there in 2.7 grams of aluminum? 2.7 grams of aluminum. Grams is here, atoms is here. So you put the 0.7 grams here, you don't put it here, you put it where grams is. So 2.7 grams of aluminum. So 2.7 grams of aluminum will contain what? Will contain how many atoms? How many atoms of the element? Okay. This question mark, you can put X here, any alphabet of your choice. And when you cross multiply either and you make X the subject, so X becomes 2.7 times 6.02 times 10 raised to the power 23 all over 27. Okay, so this when you use a calculator for this, at the end of the day, you will get 6.02 times 10 raised to the power 22 atoms. So this is the number of atoms in 2.7 grams of aluminum. Option A, 5.08 times 10 raised to the power 22, wrong. Option B, 6.02 times 10 raised to the power 22, correct. All other options are wrong. Option C is 3.01 times 323, wrong. Option D, 6.02 times 323, wrong. Option E, 6.02 times 10 raised to the power 24, wrong. So the correct answer is 6.02 times 10 raised to the power 22. Option B. Number 11. Which of the following element is diatomic? Which of the following element is diatomic? Diatomic. The prefix di, it means two. Element that has two atoms. Either two atoms in the on a macroscopic scale. On a macroscopic scale. Okay. So we have option A, argon. Argon, we have argon. Argon is group 8. It's a group 8 element or noble gases. Are you there? Argon, no. Carbon, no. Argon is carbon is monoatomic. Are you there? So we have iron. We have iron, Fe, monoatomic also. Oxygen, oxygen is diatomic in nature. Okay, oxygen is diatomic in nature. That's O2. Okay, we have sodium. Sodium is monoatomic, Na. So the correct answer is what? Oxygen gas or oxygen. Then which of the following element is diatomic? Oxygen. Option D is correct answer for number 11. Okay, let's go to number 12. The chemical process that is represented. We are given a chemical equation here. Given a chemical equation here. So let's show it on the board. So, chemistry is interesting. Chemistry is life. H2O. Life is all about chemistry. Okay, without water you cannot exist. Can you exist? No. Without water you cannot exist. Even you are fasting on mountain, you fast for like 100 days. I don't think you will die because no water, no food, nothing. Okay, so chemistry is life. H2O. All right. Number 12. The question says the chemical process that is represented by the equation below is, we are given sodium carbonate decahydrate, that's Na2CO3 dot 10H2O, Na2CO3 dot 10H2O. Okay, given Na2CO3 dot H2O plus 9H2O. Okay, it said this is a gas, this is solid, and this is a solid. So Na2CO3 dot 10H2O to give Na2CO3 dot H2O plus 9H2O. They said The chemical process that is represented by the equation below is this. So is what? Is what? Option A, combustion. Option B, deliquescence. Option C, effervescence. Option D, efflorescence. Option E, hygroscopy. Chemistry is simple. You just have to know what each of the terms represents. Are you there? So combustion is out of it. Combustion is wrong. Are you there? So combustion is wrong. So that is the process by which a chemical substance is reacted with oxygen gas. Are you there? So to form different products, to form carbon dioxide and water plus energy. That is combustion. Are you there? So we are not. This reaction is not. It has nothing to do with combustion. Now option B, deliquescence. Deliquescence is a phenomenon that occurs when a chemical substance absorbs moisture from the air, absorb moisture from the surrounding, which is enough to form a solution. Okay, for example, now when you go to the lab, you see sodium hydroxide pellet. Sodium hydroxide pellet, it is in a kind of a plastic bottle. So when you open the lid, before you know it, the pellet are in solid form, small like this. Are you there? Like a seed. Okay, so immediately you open the bottle of that sodium hydroxide pellet, it becomes watery. Chinekele. It becomes wet. That means it has absorbed moisture. It has absorbed moisture in form of water from the air. And don't forget that one of the compositions of air is water vapor. Okay, so and water vapor is obtained from the evaporation of water from the sea surface, ocean, rivers, and all that. So that is deliquescence. So option C is effervescence. Effervescence is the release of gas. The release of gas to the surrounding in a chemical reaction. When a gas is released to the surrounding, we said effervescence has taken place. That is a term in chemistry, effervescence. Option D, efflorescence. Efflorescence is the opposite of deliquescence. So efflorescence is the process or is a phenomenon that occurs when a chemical substance releases moisture, releases water to its surrounding, releases water to air, into the air. Look at this, Na2CO3.10H2O. This is sodium carbonate decahydrate. Are you there? Also known as washing soda. Are you there? You can see that the product gives us Na2CO3.H2O plus 9H2O. 9 molecules of water has been separated from the 10 molecules of water. So this 9 molecules of water has been released to the surrounding, has been released to air. Okay, so this is a good example of efflorescence. So option D is the correct answer. Efflorescence. So option E, hygroscopy. Hygroscopy also has to do with absorption of moisture from the air, but which is not enough to form a solution. Where concentrated sulfuric acid is a good example of this. Copper 2 oxide is a good example of this. Also, it is not enough. Hygroscopy absorbs moisture from the surrounding, but not enough to form a solution. Okay, but the correct answer is of efflorescence. Efflorescence, that is when it releases water molecules to air. Option D is correct answer. Let's go to number 13. Number 13, the type of chemical bond that exists between potassium and oxygen in potassium oxide. The type of chemical bond that exists between potassium and oxygen in potassium oxide is A, covalent bond, B, dative bond, C, hydrogen bond, D, ionic bond, and E, metallic bonds. Let's look at them again. We have the type of bond that exists between potassium and oxygen in potassium oxide is, look at potassium oxide. This is potassium oxide. That's potassium oxide. K2O. Are you there? So potassium 19, that's 28. The atomic number is 19, that's 2881. Are you there? Oxygen atomic number is 6, atomic number is 8, and that's 26. Okay, 26. So the element potassium we give out this valence electron, this one to this. Oxygen has 6 electrons at the outermost shell, so it needs 2 more electrons. It needs 2 more electrons to become octets, to become 8. Are you there? So it needs 2 more electrons to become 8. So it will accept that 2 electrons from the neighboring element, and the neighboring element there is potassium. Okay, so potassium that means two of potassium is needed. That means 2 of potassium is needed to have 2 electrons. So when we have 2 of potassium, we have 2 electrons that will now be given to 1 oxygen. That will now be given to 1 oxygen to make it 8. So whenever there is a transfer of electrons from a metallic element to a non-metallic element, are you there? Electrovalent bond occurs. So another word for electrovalent bond is what? Ionic bond. Okay, so let's look at the options. We have option A, covalent bond. Option B, dative bond. Option C, hydrogen bond. Option D, ionic bond. Then we have option E, metallic bond. Option E, metallic bond. Okay, so covalent bond is when there's sharing of electrons between 2 atoms. Dative bond is the sharing of lone pairs of electrons. Yes, so lone pair, when an atom donates a lone pair of electrons to the neighboring atom. So we also have C, hydrogen bond, where hydrogen bond occurs in substances where we have hydrogen as an element, but the hydrogen must have a certain electronegativity values. Are you there? It mostly occurs in halides. And some gases like water, H2O, ammonia gas. Are you there? Ammonia gas, water H2O, we have hydrogen bond, ammonia gas, we have hydrogen bond, and then phosphine is PH3, phosphorus hydride. Are you there? So we have all that. So is that is not an answer. Option D, ionic bond. Yeah, ionic bond, when there is transfer of electrons from the metallic element to a non-metallic element. Option E, metallic bond. That's the kind of bond that occurs in a metal. So option D is the correct answer, ionic bond. Number 14. The elements in group 1 of the periodic table are called elements in group 1 of the periodic table are called what? So what do you think the answer is? Element in group 1 of the periodic table. Elements in group 1 of the periodic table. So in group 1 we have the lithium. So we have lithium. We have sodium. We have potassium. We have rubidium. We have cesium. We have francium. Those are the elements that we have in group 1. So group 1 elements are called alkali metals. Alkali metals. Group 2 are called alkali earth metals. Group 2 are called alkali earth metals. Group 3, boron family. Group 4, carbon family. Group 5, nitrogen family. Group 6, oxygen family. Group 7, halogens. Group 8, noble gases or inert gases. Are you there? So group 1 are called alkali metals. So option B is correct answer for number 14, alkali metals. Okay, so option now that was number 14. Number 15, an oxide SO2. This oxide, we are given this as an XO2. This oxide has a vapor density of 32. So the vapor density is 32. He said, what is the atomic mass of X? This X now. What is the atomic mass of X? An oxide this XO2 has a vapor density of 32. What is the atomic mass of X? Are you there? So the formula I'm going to use there, since a gas, it's going to be molecular mass molecular mass equals to 2 times vapor density. Molecular mass equals to 2 times vapor density. That's the formula. Okay. The molecular mass, okay, let's wait for that. So 2 times vapor density is given as 32, right? So that's 32. That is giving us 64. So the molecular mass becomes 64. 64 is not the correct answer. Are you there? When you look at the options, 64 is one of the options. If you choose that, that's 0 for you. Okay? So you must understand the concept. Molecular mass equals 2 times vapor density. So 2 times 32, that's 64. That's the molecular mass. But the concept, you find the atomic mass of X, mass of this. Do you understand? If you want to get the molecular mass of a compound, XO2 now is a compound. Molecular mass of a compound, or molar mass is molecular mass. You add the atomic masses of the element in the compound together. You add the atomic masses of the element in the compound together. So let's add the atomic masses of the element in this compound. The element in this compound are X as one element and oxygen as another element. So atomic mass of X plus the oxygen is O2. This 2 is for oxygen. That's 2 times atomic mass of 16 is given. No, atomic mass of oxygen is given or is constant. Either is 16. Okay, so equals to the molecular mass equals to 64. Okay, so addition of the atomic masses of the element inside the compound is equal to the molecular mass or molar mass. So when you solve this, you have 32 equals to 64. You have X equals to 64 minus 32. So X equals to what? 32. So that means the atomic mass of the element is what? 32. And guess what? Either, guess what? Element with atomic mass 32 is what? Sulfur. So invariably, that means this X is sulfur. Either. So SO2, that's our fluoride gas. Okay, let's look at the options. Option A, 12. That's for number 15. And oxide XO2 has a vapor density of 32. What is the atomic mass of X? Option A, 12. Option B, 16. Option C, 20. Option D, 32. Option E, 64. So correct option is what? Option D, 32. Number 32, option D. Now let's go to number 16. Number 16. For number 16, which of the following is a normal salt? Which of the following is a normal salt? Which of the following is a normal salt? Okay, which of the following is a normal salt? We have KHSO4. Okay, we have Mg bracket NO3 close bracket 2. We have NaCl, we have ZnCl2, and we have ZnSO4. Okay, the first one is KHSO4. Okay, now this one is an acidic salt because hydrogen ions is inside the compound. Are you there? KHSO4. Because which of the following is not a normal salt? Okay, it's not a normal salt. So potassium hydrogen tetrasulfate 6 is an acidic salt, KHSO4. So that is the correct option. Either. All others are normal salt. Magnesium nitrate, or is it magnesium trinitrate 5 is a normal salt. Sodium chloride is a normal salt. Zinc chloride is a normal salt. Zinc sulfate is what? A normal salt. No hydrogen here, no hydrogen here, no hydrogen here, no hydrogen here. So it's not an acidic salt. Either they are normal salt. No hydroxy group OH. There's no OH here, there's no OH here, there's no OH here, so there's no OH here. So it's not a basic salt either. So all these ones are normal salt except KHSO4, which is an acidic salt. So for number 16, the correct option is option A. Number 17. The product of the electrolysis of dilute sodium chloride solution with platinum electrodes are the product of the electrolysis of dilute sodium chloride solution with platinum electrodes are option A, chlorine and water, option B, hydrogen and chlorine gas, Option C, hydrogen and oxygen gas. Option D, sodium amalgam and chlorine. Option E, sodium hydroxide and water. So when you electrolyze sodium chloride solution, you are having two compounds there, sodium chloride and water. The word solution means that water is there. And you know that electrolysis is the chemical decomposition of a compound either, so either in molten state or in solution when a current passes through it. So we're having sodium chloride. The sodium chloride we ionize either in a solution to give sodium ions and what? Chloride ions. Then the water molecule, there's water in every electrolyte either. So the sodium chloride is an electrolyte, so there's water inside it either for any electrolyte. So the water we ionize into hydrogen ions and hydroxide ions either. So we now come to the anode. The anode is a positive electrode and the cathode is a negative electrode either. So at the anode, which is the positive electrode, those ions that are negatively charged will migrate to the anode. That is Cl- and OH- that are negatively charged, they will come to the anode side because like charges repel, unlike charges attract. So the one of Cl- and OH- will come this place. Either the positive electrode will attract the negative ions, unlike charges attract. While the cathode is negatively charged, so it will attract the positive ions, to attract sodium ions and hydrogen ions. So that is Na plus and H plus. Okay, it will attract all these. So there will be both anodes are platinum electrodes that will dip inside the electrolytes. Okay, so the at the anode, at each of the electrode, there will be competition as to which the one that will preferentially discharge. Okay, and you can't just say, oh, this one is discharged or this one displays. It is based on three factors either, but one is dominant. The most dominant is what I'm going to use. When you look at the reactivity series where we have potassium, sodium, calcium, and all that. So the one that is above will displace the one that is below. And the one that is above will displace the one that is below. Okay, that is the one that is at the top of the reactivity series. We kick out the one that is at the bottom of the reactivity series. So reactivity series, we have potassium, calcium, magnesium, aluminium. That scientists can make is zinc, iron, like that, hydrogen, copper, like that. So when you look at reactivity series, you find that sodium ions is far above hydrogen ions. Sodium ions is far above hydrogen ions. So sodium ions we kick is, that means it's stronger than hydrogen ions. That means sodium ions will kick out hydrogen ions. Sodium ions will kick out hydrogen ions. Hydrogen ions will come out of the solution. So at the cathode, hydrogen ions will come out of the solution because it is below sodium ions. So it will come out hydrogen ions from the solution. So hydrogen from the solution. So that hydrogen ions at the cathode we have gain of electrons. At the cathode we have gain of electrons. So the hydrogen ions will gain electrons at the cathode either to form hydrogen gas. So we balance. Okay, aqueous. So whenever hydrogen ions is kicked out of the solution, it turns out to be hydrogen gas. So the product obtained at the cathode is hydrogen gas. At the anode, we have chloride ions and hydroxide ions. So also in the reactivity series for negative ions, in addition to negative ion, we have SO4 2-, NO3-, chloride ion, bromide ions, iodine ion, hydroxide ions in that order. SO4, SO4 2-, NO3-, Cl-, bromide ions, iodine ions, hydroxide ions. So the one above also displays the one below. That is Cl- is above OH-. So Cl- will displace OH- from the solution. Cl- will displace because Cl- is above OH- in the reactivity series for negative ions. Are you there? So Cl- will displace we kick out hydroxy ions. So that means hydroxy ions will be out of the solution. Are you there? So whenever hydroxy ions is out of the solution, it will turn out to become water as a product in that particular electrode. But there's a condition. Though based on the reactivity series, based on the position of the ions in the electrochemical series or in the reactivity series, we know that Cl- is above OH-. So Cl- should be stronger. So Cl- should be able to displace, should be able to kick out OH-. Are you there? But that will not occur practically. It won't occur. So when it comes to chlorides, we have chloride ions. The Cl- and OH-, we see them that the Cl- they are called concentration effect. Concentration effect for chloride ions. The chloride ions they work based on concentration effect. Okay, so instead of OH- to be kicked out, to be displaced from the solution, it's Cl- that will be displaced from the solution. It's Cl- that will come out. Are you there? So if you use the position of Cl- and OH- in the reactivity series to judge, are you there? You are going to have OH- being kicked out, which will lead to a wrong answer. Are you there? So their position in the reactivity series is not effective. It's not effective as far as these two ions are concerned. So you are going to use Cl-. So Cl- will be kicked out because of what we call concentration effect. So whenever Cl- is kicked out at a particular electrode, it will, anode. At the anode, there is loss of electrons. Loss of electrons occurs at anode. Loss means minus E-. Are you there? E- is the electron. So we have Cl2. So this is a gas. Then you balance it. Okay, this is aqueous. So this is the anodic half-cell reaction. That means at the anode, chlorine gas is the product. At the cathode, this is cathodic half-cell reaction. The hydrogen gas is produced. So let's look at the product. Let's look at the options. So the product of the electrolysis of dilute sodium chloride solution with potassium electrodes are option A, chlorine and water. No. Option B, hydrogen and chlorine gas. Yes, hydrogen and chlorine gas. So option C, hydrogen and oxygen gas. Option D, sodium amalgam and chlorine. No. Sodium amalgam is when mercury attacks sodium. When mercury attacks sodium, it forms sodium amalgam. That is in the electrolysis of concentration sodium chloride, known as brine. Okay. The option E, sodium hydroxide and water. No. So our correct answer is hydrogen and chlorine gas. So Cl- is removed here. Then H+ is removed here. So this one has been removed at the anode. This one has been removed at the cathode. Are you there? So we are left with Na+ at the cathode and OH- at the anode. They can also ask you in subsequent exams that what is the overall effect at the end of the electrolysis of that aqueous sodium or dilute sodium chloride. What was the overall effect, the resultant effect? At the end of the day, we have Na+ remaining in the cathode. We have OH- remaining in the anode. So the Na+ sodium ions will react with the hydroxy ions, are you there, to give sodium hydroxide. Oh my goodness, sodium hydroxide. So that means sodium hydroxide is an alkali. Are you there? So that means the resultant effect is that the electrolyte becomes alkaline in nature. It becomes alkaline in nature, or you say basic in nature. That means the pH will have exceeded 7. That is the meaning. The pH will exceed 7. So in the subsequent exams, so our correct option is option B, hydrogen and chlorine gas, for number 17. So let's go to number 18. For number 18, we have what current in amperes will deposit 2.7 grams of aluminium in 2 hours? This is a calculation under electrolysis. Don't forget Faraday's laws of electrolysis, Faraday's first law of electrolysis, Faraday's second law of electrolysis. Okay, don't forget them. Okay, we apply those ones in calculation. Okay. So Faraday's first law of electrolysis and Faraday's second law of electrolysis. So they said what current in amperes we deposit 2.7 grams of aluminium in 2 hours. We are given the mass of aluminium. We are given the mass of aluminium as 27 grams. No, 2.7 grams. 2.7 grams in the question. Mass of aluminium as 2.7 grams. We are given time as 2 hours. Time as 2 hours. Then they gave us the atomic mass of aluminium. Atomic mass of aluminium as atomic mass of aluminium as 27, and they were given 1 Faraday as 96500 coulombs. 1 Faraday. 1 capital letter F. Capital letter F is 1 Faraday. 1 Faraday is 96500 coulombs. Okay. Now, how do you solve this? How do you find what current in amperes we deposit 2.7 grams of aluminium? You know, one of the formulas in this particular aspect is Q is equal to IT. Q equals to IT. Okay, Q is the quantity of electricity that flows through the source, are you there, in order to deposit the particular element. Okay, so I is the current in amperes and T is the time in seconds. Is that taken? So as you can see that we are given time. We are given time, right? We are given time, and then we are looking for current, and we are looking for current. We are given time, we are looking for current. Time is given. We are looking for I. We don't know Q. We don't know Q. We don't know Q. We are looking for I, and we know T. It's impossible for us to have 2 unknowns in a particular formula. Are you there? So that means we need to go and get Q. That means we need to go and get Q, the quantity of charge first. Are you there? So how do you get Q? You look at the element involved. The element involved is aluminium. Aluminium. What is the valence electrons? What is the valency of aluminium? The valency of aluminium is 3. The valency of aluminium is 3. So that's what you are going to use to get your one of the hints that you are going to use to get the answer. So the valency of aluminium is 3. So it means that you write the cathodic reaction, cathodic half-cell reaction. So at the cathode, so at the you have aluminium 3 ions. Are you there? At the cathode, it accepts 3 electrons. Give aluminium solid aqueous. Aqueous. Are you there? So aqueous, we have this like this. So 3 minus 3, that's 0. It becomes 0. So when you write the anodic half-cell reaction, cathodic half-cell reaction, the number of moles of the electrons is 3. So you are going to use this 3 as your number. As one of the hints to solve. Okay. If it is sodium ions, Na plus, that means here is going to be 1. If it is copper 2 ions, Cu2 plus, that means here is going to be 2. And they are going to use 2. If the silver ions, Ag plus, is going to be 1, like that. Do you understand? Aluminium is 3. So this is an objective question. You may not write the reaction, but the aluminium ions is A03 plus. So this 3 is what I'm going to use. So it means that 3 Faraday. It means that 3 Faraday of electricity is equivalent to 1 mole of the element. 3 Faraday of electricity is equal to 1 mole of the element. If you have sodium ions, which is plus 1, which is 1, you say 1 Faraday is equivalent to 1 mole. This is copper 2 ions, which is 2 plus. You say 2 Faraday is equivalent to 1 mole of the element. And 1 mole of any element is its atomic mass. 1 mole of any element is its atomic mass. And that's why we are given the atomic mass of aluminum at 27. So now say 3 Faraday of electricity will discharge 1 mole of aluminum. And 1 mole of aluminum is 27 grams of aluminum. Is that taken? And then this Faraday, 1 Faraday is given as 96500 coulombs. So it's going to be 3 times 96500 coulombs. Are you there? To give 27 grams. So 3 times 96500 coulombs to give 27 grams. So these are watchword now. 3 times or numbers. 3 times 96500 coulombs is equal to what? 27 grams. So now This left-hand side is for coulombs, which is quantity of electricity, while this right-hand side is for grams, which means mass of the element discharged. And you know that we are given the mass of the element as 2.7 grams. 2.7 grams. So you now put this 2.7 grams at the side of mass. This right-hand side is side for mass. So you put your 2.7 grams here, which is side of the mass. Then you find a particular number here, question mark, right? So 3 times 9650 coulombs gives 27 grams. Then what amount of electricity will give 2.7 grams? So you can put any alphabet of your choice there. Let's put this question mark, let's put X. Okay, so when you cross multiply and you make X the subject, you have your X as 3 times 96500 times 2.7 over 27. Okay, and at the end of the day, when you multiply it with your calculator, you have 3 times 96500, okay, times 2.7 equals to, divided by 27. We have it as 2. We have X as 28950 coulombs. 28950 coulombs. That's the quantity of electricity that's required to discharge 2.7 grams of the aluminum. 28950 coulombs. Are you there? That is not your final answer. That's not your final answer. You now go back to Q equals to IT. Q is equal to IT. So your Q, which unit is coulombs, is this T28950 coulombs. Are you there? Then I is what you're looking for, current. T is the time. The time is given in hours. You must convert it to seconds. The time must be converted to seconds. So when you convert 2 hours to seconds, you multiply it by 3,600. That is 2 times 3,600. You have it as 7,200. So 7,200 seconds. Convert the time in 2 hours to seconds. That's 2 times 3,600. You have it as 7,200 seconds. Okay. So you now substitute in the formula as Q equals to IT. What's your Q? Your Q is 28950 equals to, what's your I? You are looking for I. Multiply by, what's your time? Our time is 7,200. 7,200. Are you there? So making I the subject, so I equals to 28950 over 7,200. So we have 28950 divided by 7,200. So we have it as 4 points. We have it as 4 points. We have a 4.02. So that's 4.021 amperes. 4.02 approximately to a whole number. That's 4 amperes. That's 4 amperes. Okay. So we have our options as option A 4, option B 8, option C 16, option D 32, option E option A 4, option B 8, option C 16, option D 32, option E 34. Okay. So what current in amperes will deposit 2.7 grams of aluminium in 2 hours? Are you there? So correct option is option A, which is 4 amperes. 4 amperes is the correct answer for number 18. For number 18. So then we have number 19 and 20. We have number 19 and 20. So let's have number 19 and 20. Okay. For number 19, the question says a current of 4 amperes was passed through copper 2 tetraoxide solution for 1 hour using copper electrodes. A current of 4 amperes was passed through copper 2 tetraoxide solution for 1 hour using copper electrodes. Calculate the mass in grams of copper deposited. The question is on the same topic with number 18, electrolysis. So they said a current of 4 amperes was passed through copper 2 tetraoxide solution for 1 hour So we are given the current as 4 amperes. Are you there? So we are given the time as 1 hour. 1 hour to seconds, that would be 1 times 3,600. That's 3,600 seconds. So with this, you can get your Q. Q equals to IT. So the current is 4, the time is 3,600 seconds, and that gives us, when you multiply it together, that's 3,600 multiplied by 4, that gives us 14,144,00 coulombs. That's the quantity of electricity required to displace or to start the elements. Are you there? So the answer said a current of 4 amperes was passed through copper 2 test out of a C solution for 1 hour using copper electrodes. Calculate the mass in grams of copper deposited. So since it is copper 2 tetrate of a C, that is, it is CuSO4. Okay, it will ionize to give copper 2 ions, either plus SO4 2 minus. That is, the cathodic reactions will be this: copper solid and aqueous. That means 2. 2 is the valency, either. So 2 electrons. So we now use this 2, as I have told you before. We now use this 2. So 2 Faraday of electricity will give 1 mole of copper, and 1 mole of copper is its atomic mass, which is given as 64. Are you there? This 2 Faraday, you change this Faraday to 96500 coulombs. It's given. It's a 1 Faraday is 96500 coulombs. So it's going to be 2. It's going to be 2 times 96500 coulombs to give 64 grams. Are you there? Then this one is in coulombs, and you have gotten this one also 14440 in coulombs. So coulombs will come under coulombs. Are you there? So 14400 coulombs will give question mark, which is, this is the mass we are looking for. Question mark. That question mark can be any alphabet of your choice. Let's use X. Then you cross multiply. You have X equals to 14400 multiplied by 64 divided by 2 times 96500. So let's quickly multiply that. So we have 1440000 multiplied by 64. That gives us this. Divided by 96500 equals to, divided by 2. I have it as 4.775, approximately 4.8 grams. Okay, 4.8 grams. Let's look at the options. Option A, 3.2. Option B, 4.8. Option C, 6.4. Option D, 48. Option E, 96. So our correct answer is what? Option B, 4.8. A current of 4 amperes was passed through copper 2 test of a C solution for 1 hour using copper electrodes. Calculate the mass in grams of copper deposited. They give us atomic mass of copper as 64 and 1 Faraday as 96500 coulombs. So the correct option is what? Option B, 4.8 grams. So let's look at number 20. Number 20. Which of the following is a basic salt? Which of the following is a basic salt? A basic salt, you know, we have types of salt. We have normal salt, acidic salt, basic salt, double salts, and all that. Do you understand? So double salts and then complex salts. Okay, so we have the options here. They say which of the following is a basic salt. We have Mg bracket NO3 2, option A. Option B, we have Mg bracket OH close bracket NO3. Then we have option C, NaCl. We have option D, Na2CO3. And we have option E, Na2SO4. Option A is MgNO3, that is magnesium triiodide 5. That one is a normal salt. A basic salt contains hydroxy ions as one of the ions in the as a main ion in the salt. So magnesium triiodide 5 is a normal salt because it doesn't have OH minus hydroxy groups. Option B, magnesium hydroxide triiodide 5. This one has hydroxy group as one of the ions. Are you there? So this is a typical basic salt. Are you there? So this is our answer. Look at this one. Sodium chloride is a normal salt. Sodium triiodide 4 is a normal salt. Sodium sulfate is a normal salt. So it's only magnesium hydroxide triiodide 5 that is a basic salt because it contains the hydroxy group OH. Thank you so much. We stop at number 20. So we'll continue from number 20 in our next class. Okay? And don't forget that this is chemistry, NECO, the one that was written on the 28th of July this month. Okay, my my explanation will enable you to pass the WAEC that is coming up next month. Okay, the topics in NECO and WAEC, they are the same thing. Okay, they are the same thing. Thank you so much. Bye for now.